Extrusion is a plastic deformation process where a metal block, known as a billet, is forced to flow through a die with a smaller cross-sectional area. This method is effective in reshaping materials through compression. During extrusion, indirect compressive forces develop as the billet reacts with the container and die. This creates high compressive stresses which help prevent cracking in the billet material during processing. There are two main types of aluminum extrusion: hot and cold. Hot extrusion involves preheating the billet to make it easier to deform plasticity, while cold extrusion uses the billet at room temperature. The direct extrusion method is the most commonly used for aluminum. In this process, the billet is pushed through the die by a ram, producing various shapes like rods, profiles, and tubes, with metal flow aligning with ram travel. As the billet is pushed through the die in direct extrusion, it slides against the container walls, increasing frictional resistance, which in turn raises the ram pressure required for extrusion. In contrast, indirect extrusion involves the die moving relative to the container, while the billet remains stationary. This eliminates friction between the billet and container, altering the dynamics of the extrusion process. Curves of extrusion pressure versus ram displacement demonstrate the differences between direct and indirect processes. Initially, pressure rises significantly due to the compression of the billet and the equipment, elastic deformation. In direct extrusion, the rise in pressure from point A to B is caused by friction between the billet and container, while the maximum pressure at point B marks the start of metal flow, known as breakthrough pressure. In direct extrusion, the rise in pressure from point A to B is caused by friction between the billet and container, while the maximum pressure at point B marks the start of metal flow, known as breakthrough pressure. As the extrusion process continues in direct extrusion, the pressure required to maintain the metal flow decreases because the length of the billet in the container reduces, decreasing frictional resistance. For indirect extrusion, as there is no movement between the billet and container, the extrusion pressure remains relatively constant, creating a different dynamic in the extrusion process. Beyond point C in the direct extrusion curve, the pressure rises rapidly because the metal's flow direction becomes more perpendicular to the applied force, impacting how the billet deforms during extrusion. This video provided a brief overview of aluminum extrusion. For detailed information, please check the sources linked in the description below. Thank you for watching. If you enjoyed this video, please like, comment, and subscribe for more content.